I'm back. All right, it's time to go over Math Minute 23 and 24 because you'll have a Math Minute quiz tomorrow. So we want to make sure that you get both of these down and have time to ask any questions that you might have. So we're going to start by rounding each number to the nearest thousand. We're going to start in thousands place. We're going to underline and look behind. I have a 2 here. So 2 is too small to make a difference. So we're going to leave the thousands place as a 1, and then every number beyond it is going to go ahead and turn into a 0. That's because we're rounding to the nearest thousand, and in this case, I'm saying that I'm closer to 1,000 than I am to 2,000. Same here, I'm going to look at the thousands place. I'm going to underline and look behind, and here I have an 8. 8 ate the rest of the numbers, so it got fatter, which makes our 1 instead into a 2. And then all the numbers behind it turn into zeros. In this case, it is again because 1,850 or 1,850 is closer to 2,000 than it is to 1,000. Then we have 3,320. Underline the thousands place, look behind to the 3. And we have our thirsty 3 that's going to remain parched because it's so small. This 3 remains the same, and the other numbers behind it become zeros because we're closer to 3,000 than we are to 4,000. All right, which of the following letters has 2 lines of symmetry? So make sure I underline that. I like to underline important words in instructions so that I make sure that I am doing exactly what it's asking me to do. So for the H, I could go right across the top there, or right across the middle, and I could fold it up or fold it down, and I'd get exactly the same no matter which way I folded it. And I could also split it down the middle, and again, I'd get exactly the same no matter how I folded it, left or right. So we know that H has 2 lines of symmetry, and just in case this is playing a trick on me, I'm going to double check and make sure no other letter has 2 lines of symmetry. W, I guess, depending on how you write a W, you could potentially split it down the middle and get a symmetrical letter. However, there's no other way to split the W so that you get a second line of symmetry. With L, there is no line of symmetry at all. I can't cut it across the middle. I can't cut it down vertically. I can't even cut it diagonally to get the exact same thing. With V, I can cut it down the middle, and I should be able to fold it vertically left or right and get the same letter. But again, there's no way for me to do that across the middle, just like with W. So in this case, H is the only letter that has 2 lines of symmetry. 1/4 of 12. So again, remember that of is indicative of multiplication. So we have 1/4 of, or multiplied by 12 over 1. 1 times 12 is 12. 4 times 1 is 4. And that gives me 12 divided by 4, which is 3. Now again, we have something that you will see later on, 1/4 of 12, or 1 part of 12 once it's been split into 4 groups. Well, I know that 12 divided by 4 is 3, and if I'm only looking at 1 part of that, I'm only looking at 3. Okay, if 1/5 plus 1/5 equals a fifths, then we know that when we're adding, our denominator remains the same, but we do actually add across the top. So we add our numerators, and in this case, we have 1/5 plus 1/5 is going to be 2/5. But we're only looking for the letter A. I'm not looking for 2/5. This is 2. The reason I'm telling you that is because if you were to put this kind of an answer on a test and say it's 2/5, basically you're telling me it's 2/5 fifth. And that, first of all, doesn't even look right. But ultimately what you're really telling me is that 2/5, 2 divided by 5 divided by 5, you're giving me a division problem, 2/5 divided by 1/5, and that gives you a whole nother slew of issues. So here we go. Let's practice order of operations. Until I know you guys are absolutely fantastic at it, I'm going to just go ahead and write PEMDAS up here at the top just so we don't forget. Our order of operations, remember that division and multiplication go in order from left to right, and subtraction and addition go in order from left to right. So we're going to start with parentheses, there are none. Next is exponents, there are none. Then there's multiplication. And in this case, it's 4 times 2. Remember, we only want to do one step at a time so that we don't rush things. When we rush, we tend to make mistakes. So then we have both their addition, so I can go ahead and just do them in order from left to right. 3 plus 8 is 11, and that leaves us with 11 plus 6, and then 11 plus 6 is 17. Okay? Again, you got to follow that order of operations. It's there for a reason. If you don't do that, it's going to give you a totally different answer. If I were to try and just go from left to right, I'd get 3 plus 4, which is 7, 7 times 2, which is 14, and then 14 plus 6 is 20. That's different than the answer I got, which was 17. So again, please make sure you're practicing the correct order of operations. We're going to complete the pattern box here. 2, 10, 5, 25. I already see the pattern. 2 times 5 is 10. 5 times 5 is 25. 8 times 5 is 40. And 12 times 5 is 60. Okay, so hopefully you saw that pattern. If not, oftentimes just make sure when you go from one to the next that it follows the pattern all the way through. And in this case, they only gave you 2 times to practice that pattern, so you really had to look at what they had in common. Number 7, if the perimeter of this shape is 25, then x equals what? Okay, so this is an algebra problem. Perimeter means plus. So I've got 5 plus 5 plus 6 plus 4 plus x. So I need to figure out what x is. So the first thing I'm going to do is I'm going to put this equal to 25. And I'm going to add up these 4 numbers here. The nice thing about this is the way I put them in order is I see that 5 and 5 is 10. And 6 and 4 is another 10. So I have 10 plus 10, which is 20. So really I have 20 plus some number is going to give me 25. Again, if algebra is something that throws you off, if the fact that this is a variable throws you off, you need to start getting used to it, but you could look at it like this, and I'm going to write this off to the side, and I'm going to write it in a different color. Red probably won't show up as differently, so I'm going to use brown. Really, this is just what you've been looking at since kindergarten. 20 plus a blank box is equal to 25. The only thing that we've done between kindergarten, or this is probably more like first grade math, but since that time and sixth grade is I've changed my box from a box to a letter. So again, I'm 20 plus some unknown number equals 25. And the same here, 20 plus some unknown number equals 25. In both cases, these are like superheroes. We're trying to unmask them and find their secret identity. So if I do look at this, I know that 25 minus 20 is 5. So the secret identity of x is going to be 5. And that makes perfect sense. 20 plus 5 is 25. If I add around the edges, 5 plus 5 is 10, plus the other 5 is 15, plus 6 is 21, plus 4 is 25. All right, the sum of the third shaded column is, again, remember columns are vertical, they hold buildings up. So we're looking for the third column, and we're looking for sum. So we're adding. We're going to add 9 plus 6 plus 7. 9 plus 6 is 15. 15 plus 7 is 22. And I'm going to leave this answer right here just because I wrote so low in the previous problem that I almost invaded the space. So then we have some pretty straightforward multiplication. Again, note that multiplication can be written in multiple ways. This is still multiplication, all three of these. So 9 times 6 is 54. 9 times 8 is 72. And 9 times 9 is 81. I want to go ahead and keep reminding you guys of things like this, but 9 times 9 is the same as saying 9 squared. I have 9s, and then I have 2 of them, so this is 9 squared. Okay, we have some more of that algebraic equations, of those algebraic equations. And so again, I'm just going to go ahead and show you that this is really x divided by 4 equals 9. If you wonder why I keep showing you this way, it's because when we start to get into algebra, I don't want you to fear it. I don't want you to see it as something completely and totally foreign that we've never talked about or looked at before, because ultimately I want you to see it as something that you've been doing for an awfully long time and something that you're really already good at. So we have x divided by 4 equals 9, or what's in the box divided by 4 equals 9. So I have to think, what number, what secret identity would I reveal when divided by 4 will give me 9? Well, the opposite of dividing by 4 is multiplying by 4. So if I work this backwards and I say, okay, I'm not going to divide by 4 here, I'm going to multiply by 4, and then I'm going to multiply this side by 4. 9 times 4 is 36. So then I have to double check by doing the work. And I say 36 divided by 4 is indeed 9. Therefore, I know the secret identity hidden by my x, or hidden within my box, is 36. Again, here I have x divided by 6 equals 8. And I'm now looking for what is x. Well, 8 times 6 is 48. That means 48 divided by 6 is 8. And that's true. Again, my secret identity of my variable, as well as the secret identity of my box, is revealed to be 48. Over here, again, I have a box divided by 5 equals 7, just because I want you guys to see that a variable can be written in multiple ways as well. I'm going to choose the letter N for number. A number divided by 5 is equal to 7. When we talk about variables in math, we inevitably just kind of start showing you things and don't point out that you can use almost any letter that you'd like. However, we tend to start students out with the letter X, but it is not unusual to see other letters as well. So if you see another letter, don't get confused because it's not X. It's still the same idea. This still is some masked superhero that we need to uncover their secret identity. 7 times 5 is 35. So the masked identity of this box is 35 divided by 5, which equals 7. Again, it's the secret identity of our N. Okay, I'm going to do math minute number 24, and I'm going to do this, go through this one, I think, a little bit more quickly. What is the value in cents of 10 quarters and 2 dimes? Well, 10 quarters is $2.50, and 2 dimes is just 20 cents. And so what I have is $2.70. And again, I know that 4 quarters makes $1. 8 quarters would make $2, and then 2 extra quarters would make 50 cents, and then 2 dimes. Which of the following represents a line? Lines go on forever in both directions. So in this case, that would be A. I know I'm going to be giving away future answers here, but B is a line segment. It's a piece of a line, and because it's a piece of a line, it does not go on forever in either direction. And then C is what we call a ray. And I tend to think of these as, think of like a ray of sunshine, right? It has, the sun is its starting point, and then it goes on forever beyond Earth, out into space until it is swallowed by the darkness of everything. So ray has an end point and goes on forever in one direction. A line segment is an end point on both sides because it's just a piece of a line, and a line goes on forever in both directions. Which fraction represents 15 divided by 2? So we read these as 2 divided by 15, 15 divided by 2, 15 divided by 15, and 2 divided by 2. So the answer is B. Number 4, I have 2/7 plus 3/7. When we add fractions, we leave the denominator the same, and then as long as they're like denominators, and then we add across the top. 2 plus 3 is 5. And when I say across the top, I do mean across the numerators, I'm sorry. Okay, we have another problem involving a box. So really what we're looking at here is 4 plus 7 plus B for box equals 32. Okay, 4 plus 7 is 11. 11 plus B for box equals 32. And if I take away 11 on this side and then take away 11 on this side, what I'll be left with is 21. Sorry, it took me a second to write that. When you're, again, if you're curious as to why I went ahead and took away 11 from each side, imagine that you're looking at a balance and you have to keep them even. Well, if I take something from this left side, it's going to upset the balance, and this side is going to go way down. So in order to keep them balanced, I have to take the same amount from both sides. And in this case, it would leave 21 on each side. So we have 21. Okay, fill in the empty square to the right by following the pattern given. We have 3 times 3 equals 9. 8 times 3 equals 24. 6 times 3 equals 18. I've done multiplication to get from the top number to the bottom number. If I want to get from the bottom number to the top number, I have to do the inverse operation, which is division. So I'm going to do 30 divided by 3, and I'm going to see that my top number is 10. The width of a rectangle is 4 feet. So I have area equals length times width. I know the width is 4, so I'm going to plug this back in. And I'm going to say, okay, my area is 36. And I know that that is 4 times my length. So again, balancing, if I'm going to get rid of my 4 on this side by dividing this by 4, I have to divide this side by 4 as well. And I'll see that my length is 9. But I always have to include that unit of measurement. I'm talking about feet, so it's 9 feet. And that makes sense. 9 feet times 4 feet is 36 feet squared. Find the sum of the first column. Notice they didn't shade it for you this time, but I did give you the arrow. I wanted to remind you that column does go vertically up and down. It holds up a building. And we're finding the sum. 1 plus 5 is 6, plus 4 is 10. Here we're just multiplying. Any multiple of 10, we're adding the number of zeros to the end of the number. So 86 times 10 is 860. 93 times 10 is 930. 50 times 50, I'm going to do 5 times 5, which is 25. And I'm going to add the 2 zeros that are present, and I'm going to get 2,500. 60 times 60 is 6 times 6, which is 36, and I'm going to add the 2 zeros, and I get 3,600. Knowing those basic facts can help you answer all sorts of math problems and do so at a much more quick rate, or at a much quicker rate. Sorry about that. All right, there you have it. Almost 20 minutes on those two. Sorry about that.